Let's talk about simplifying some radicals, all right? So, when we're talking about a square, we want to find the area. We know the area of a square is length times width, or area is side times side, also known as side squared. All right? And so, if we want to find if we know the area and we want to find the side, we got to go a little backwards here. So suppose we got an area of a square that is 8. And if I want to find the length of the side, well, what is that length? Is it 3? No, we know 3 squared is 9, so it can't be 3. Is it 2? Well, we know 2 squared is 4, and so somewhere there is a number. Let's call it x squared, that's equal to 8. And we want to be able to describe that, all right? And you've had some experience with this most likely. If we square root both sides here, we know that we get this number. We call it the square root of 8. And it turns out that it's somewhere between 2 and 3, all right? But there's this number, the square root of 8. And we leave it as a square root of 8 sometimes. That's an exact value. Or sometimes we can go get a value and find out that it's 2 point something. So what we want to do now is we want to simplify radicals, all right? And so we're going to talk about how we can simplify a radical, a square root, all right? First, we're going to talk about what perfect squares are. We know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. So these numbers 1, 4, 9, 16, and 25, these are called perfect squares. And we got 36, we got 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121. You should be familiar with those, okay? One more, 12 times 12 is 144, okay? You want to be familiar with these here, all right? So those are perfect squares. And those are nice because we can take square roots of them easily. So when we have the square root, you should be familiar with these guys. When we have the square root of a, that means what number squared is a? So it's asking a question here, all right? And so we got our question, what is the square root of 9 in this case? Well, the square root of 9 we know is 3. Because of this guy up here, we know the square root, or 3 squared is 9, so square root of 9 is 3. What's the square root of 49? Well, that's going to be 7. We go through and we say, oh yeah, 7 times 7 is 49. How about the square root of 144? Well, going through our list here, is that a perfect square? It sure is. 12 times 12 is 144, so this is 12. Now, what about the square root of 8, that number we saw a few minutes ago? What number squared is equal to 8? What number multiplied by itself is 8? Well, 1 squared is 1, 2 squared is 4, 3 squared is 9, so there's something in the middle here. Something squared is 8, all right? And so we can go to our calculator and get a decimal, but we don't know exactly what that is. We need a way to write that. So that brings us to something called the radical product rule. And what that is this. If we have two numbers multiplied under a square root, we can break them up into 2 square roots. Okay? In other words, if we have the square root of 100, for example, okay? 100 is 4 times 25. Now, you should know what the square root of 100 is, by the way, but let's ignore that for a moment. According to this rule here, if we've got 2 things that multiply under the square root, we can write them as 2 different square roots. So the square root of 4 and the square root of 25, that's what that is, okay? Well, do you know the square root of 4? It is. I think we do. That's 2. Do you know the square root of 25? I think we do. That's 5. And 2 times 5 is 10. Now, we didn't necessarily need to do all that because we know what the square root of 100 is. Square root of 100 is 10. But check it out. It works, all right? If you have 2 things that multiply under a square root, you can take the square root of them separately, and you get your result, okay? So when we simplify square roots, we want to look for a perfect square factor. those numbers like 1, 4, 9, 16, 25, 36, so on and so forth. We want to write it as the product of two radicals, and we want to simplify the perfect square part, all right? That's how we simplify radicals. So let's try that here. So we got the square root of 20. Well, we want to look for a perfect square. Is there a perfect square that multiplies to make 20? Those again are 1, 4, 9, 16, 25, 36, so on and so forth. Well, I do believe that 4 is a factor of 20. So let's write 20 as 4 times 5. So we can break that up into the square root of 4 times the square root of 5. And we know what the square root of 4 is, right? Square root of 4 is 2. The square root of 5, I don't know exactly what that is, because 5 is not a perfect square. So we're going to leave that alone, and we write it like this, 2 times the square root of 5. Okay? This means multiplying here, it's 2 times, but this is what we call simplest radical form, all right? How about the square root of 200? Is our perfect square hiding in there? I think, remember, 100 was a perfect square. So 100 times 2 is equal to 200, right? So that's the same thing. Now we can break this up into the square root of 100 times the square root of 2. Do we know the square root of 100? We sure do. That's going to become 10. I don't know the square root of 2, so we leave that alone. Okay? How about the square root of 128? Is there a perfect square hiding in there? So we can go through our perfect squares. We notice that 4 goes into there. This is 4 times 32. However, there might be a larger one. Okay? And if we go through keep going through our list, then we'll notice that 64 is in there. 64 times 2 is 128. So we can break this up. 64 times the square root of 2, that's 8 times the square root of 2, and that is our simplest radical form. All right, what if we have something multiplied by a square root? Well, we can do the same thing. The 4 is going to hang out here. Let's break the square root of 50 up into 25 and 2. This is all multiplied here. So I got 4. What is the square root of 25? Oh, it's 5, and the square root of 2. So that's 20 square root of 2. See how that works? All right. And now one more. How about the square root of 5 times the square root of 10? That's a little weird. Well, what we want to do is we want to put that together first. So we're going to use this radical product rule up top, multiply them to get that. So put them together, we get the square root of 5 times 10, which is 50. Now we can break up 50 in a better way. That's the square root of 25 times the square root of 2, and the square root of 25 is 5. So we write it as 5 times the square root of 2, and that's our simplest radical form. So again, find a perfect square factor, write it as the product of two radicals, simplify the perfect square, and leave the other one alone. Now, one little twist on that is called the radical quotient property. Quotient, if you remember, quotient means divide. So if we're dividing two things under a radical, we can separate it into two radicals and square root at the top, square root at the bottom. So it's kind of a logical continuation of the radical product rule. So we have the square root of 3/4. We can go the square root of 3 and the square root of 4. We know what the square root of 4 is. That's 2, because 2 times 2 is 4. We don't know what the square root of 3 is, so we're going to leave that alone. It's the square root of 3 over 2. Well, what if we have 2 like this? Here we got 2 that are separated. I don't know the square root of 20. I don't know the square root of 125. But if we use the radical product or quotient property backwards, we can put it together here to one big old square root. And then I think we can simplify that fraction, right? What goes into 20 and 125? I think 4 does, right? So divide 20 by 4, we get 5. Oh, I'm sorry, 4 doesn't go in there. We're going to get a 4 in a second, but divide them by 5, right? How about that? 20 divided by 5 is 4. Divide this by 5, divide this by 5. 125 divided by 5 is 25. Now we can break it back up, take the square root of the top, take the square root of the bottom, and we get 2/5. There it is. So that's how you can simplify radicals when you're dividing or when you're multiplying. So the big idea, once again, is we want to break it up. And so we square root as much as possible. Like up here, we square rooted part of it, but we can't square root the other part. So we'll have square roots in our answer a lot of times, but it is what we call simplified.